All right, so I'm a little bit different of a presenter here in that I come from the technology side. So Kernel has built a new tool for neuroimaging, and I hope by the end of this I'll at least get your interest in wanting to explore if it might help achieve some of your goals. So the talk is, this is your brain on ketamine, but really fill in the blank with whatever it is that you are interested in. And as was mentioned in the introduction, I'll talk a little bit about some of the pilot work that we've done with Cybin using ketamine. So first, to give you an idea, I brought one here with us, and to give you an idea of what it looks like to measure one's brain using Kernel Flow, we have this picture. So this was actually captured of this participant on a ketamine trip while wearing Kernel Flow in a clinician's office overlooking the ocean. So this is not your typical neuroimaging. It's not in a basement, it's not an MRI scanner, it's not an EEG with lots of gel and setup time. So in about 5 minutes, we can get someone fitted and ready for measurement. So a little context about the study with Cybin. We're doing a 15 participant placebo-controlled study on ketamine to look at can Kernel Flow safely be used during a ketamine trip? And two, can we measure a neuro effect in response to the dose? And I'll share with you kind of high level what we see. So I should also mention during the pilot, we did one participant who was measured for 5 days before using resting state functional connectivity and 5 days after doing the same thing. And so we're able to look longitudinally at what happens before, during, and after the ketamine administration. And so we successfully got 11 days of data captured. We were able to measure the onset of ketamine, so we could see the effect of the drug as it started to work within the brain. And it was really easy. So with only a few minutes of setup, we were able to reproduce some of the results that have been shown in fMRI literature. So a little bit of detail behind what each of those points were. So first, the top pane here shows what the functional connectivity was at the beginning of the administration. So it was intramuscular ketamine, and it took about 15 minutes for this person to start to experience the effects of ketamine. After the ketamine started to kick in, the 10 minutes after the kind of initial effect, you could see a reduction in some of the cortical networks as a response to ketamine. So specifically, it's been shown that there's some activity in the default mode network that gets suppressed due to the effects of ketamine. If we look at the longitudinal data, the top pane shows the 5 days before. And what you can see here is that the functional connectivity of this person during resting state is relatively stable day to day. There's a little bit of fluctuation, as you would expect from being measured on different days, but overall, it's pretty stable. What you see on the 5 days after ketamine is that there is a decrease in functional connectivity, specifically in one particular ROI, which is related to the dorsal nexus. And I'll show you a little bit about the coupling between that node, the dorsal nexus, and the default mode network in a time course. But what your takeaway here is that we see a measurable change in the brain that lasts for a few days after having the ketamine dose. And so this is the time series of days 1 through 5 with the dosing session in between. So we measured before, during, and after. And you can see the first 5 days, we really established a baseline of what the normal brain activity of this person was. During ketamine, we see these low frequency oscillations, again, which were expected based on what we knew from the literature. And then days 7 through 11, we see a reduction in the connectivity between this dorsal nexus and default mode network. And it recovers about 5 days after the dose, which again kind of match with some of our expectations on our scientific team. So what comes next after this? So we want to introduce the concept of pharmaconeuromics. So just the same way that there is this concept of pharmacogenomics, where you can use genomic information to guide who will respond to what drugs, we think that there's an opening to use functional brain imaging to understand better what effects drugs will have on which populations. Oop, that was the wrong slide. And so similar to the genome, functional brain imaging is standardized with Kernel Flow. So all the data is calibrated in the same way. You can build large data sets and derive meaningful insights from them because everything is so standardized with how we've built it. It can be predictive. So through neurotyping, you can start to develop population level or individual neurotypes that may be more informative in selecting which groups should be given which treatments. And then finally, it's very data rich. The functional connectivity information we can pull out using Kernel Flow with 5 minutes of setup provides thousands of parameters. These parameters can enable use for things like molecule characterization, tailoring, or repurposing, so maybe reassigning it to new type of indications. So with that, my time is up, but if you want to know more, Natalie and I, Natalie over there, will be around the rest of the afternoon. We'll have the device with us, and you can email us hello@kernel.com, and we'd be happy to talk more about anything I presented. So thanks.